What evidence did Voyager 1 and 2 find outside of our solar system? In 1977, NASA used Earth to launch the Voyager 1 and Voyager 2 spacecraft. They were sent on a mission to investigate Saturn, Jupiter, and the outer planets. This was a significant achievement because no human-made object has ever attempted a journey this dangerous and far away. Once expected to run for 4 or 5 years each, the two ships have surprisingly outlasted all predictions and are still in service after 44 years. As a result, the probes have found amazing things in the solar system's periphery. Prepare to learn about it. The human race's most advanced technological achievements are the Voyager 1 and 2 probes. Voyager 1 is currently 22,000 million kilometers away from Earth, whereas Voyager 2 is 18,000 million kilometers away. Today, as a result of their considerable distance traveled, both spacecraft have left the solar system and are now traveling across the interstellar space. Many pictures of Jupiter and Saturn were taken by the two spacecraft as they traveled through the solar system. We were able to observe a lot of things for the first time thanks to the photos from Voyager 1 and 2. They photographed the structure of Saturn's rings as well as the clouds and storms on Jupiter. Active volcanoes were also found by Voyager 1 and 2 on the Jupiter's moon Io. Moreover, Voyager 2 captured the first pictures of Uranus and Neptune. Together, the two spacecraft found a total of 22 moons. Since that time, these ships have kept traveling away from us. Both keep transmitting data back to Earth. We can better comprehend the conditions in interstellar and far-off solar space thanks to this data. Through 2025, Voyagers can continue to run on their current fuel and power. They will eventually lose the ability to communicate with the Earth and will be shut off entirely for all of eternity. The Voyager spacecraft will convey the word of humanity via new stars repeatedly for millions of years unless something or someone stops them. A gold disc with images and sounds from Earth is carried by each Voyager spacecraft. Also, the discs include music and greetings in many languages. So, intelligent life will be able to learn about Earth and humans if they ever come across these spacecraft. The limits of the solar system. The layers around the solar system have been identified thanks to the Voyager missions. Years ago, the solar system's outermost point was unknown, but today we are aware that it is actually encircled by a number of layers, which are 1. Heliosphere. The area that includes all of the solar system's planets and the sun's protective layers. 2. Termination shock front. A region outside of Pluto where the solar wind has essentially no effect. 3. The heliosheath. The region at the edge of the solar system that is between the termination shock front and the heliopause. It reaches all the way to the heliosphere's boundary. 4. The heliopause. The location where solar wind interacts with stellar wind from other stars or the interstellar medium. 5. Bow shock. A region when solar radiation is no longer detectable and interstellar radiation takes over. 6. Oort cloud. The entire solar system is surrounded by a spherical cloud of asteroids, planetesimals, and microasteroids. The bow shock and the Oort cloud are the only two levels of the solar system that the Voyager probes have not yet traversed. With the speed they travel at, it is predicted that they will arrive to the Oort cloud in around 300 or 400 years and that it will take them between 30,000 and 40,000 years to completely circumnavigate the area. Unpredictable researches. A weird abnormality was discovered by the Voyager spacecraft as they traveled through the solar system's heliosheath. Perhaps you were unaware, but the magnetic fields of the planets and the Sun are highly dissimilar. This is due to the fact that matter acts differently in the Sun's core, which affects how the magnetic field behaves. On Earth, the magnetic field is more uniform at the poles, but in the Sun's core, it rotates in opposite directions at the north and south poles. The heliospheric current, which has a shape remarkably similar to the waves that occur when you drop a stone into the water, is a magnetic wave produced by this rotation of the sun's magnetic field that travels throughout the solar system. The odd thing is that although this wave is not uniform throughout the solar system, when it reaches the limits of the termination shock front, it compresses as though it were colliding with an imperceptible barrier. As the signals they sent indicated magnetic bubbles created in that location and only in that region, the Voyager probes were able to identify this anomaly. This indicates that the heliosheath's boundary is not a tranquil area as previously thought by astronomers, but rather a chaotic region with magnetic variations that interact with electrical systems on objects and spacecraft. We had to update the heliosheath model and the rest of the solar system as a result of this discovery in order to account for the fresh information. Voyager 1 made history in 2012 when it formally exited the heliosphere and became the first artificial object to escape the solar system. The fact that Voyager crossed the heliopause at a distance of 120 astronomical units from the Sun, however, led to more skepticism than excitement in the scientific community as a result of this news. Keep in mind that an astronomical unit is the approximate 150 million kilometers average distance between the Sun and the Earth. This was a significant discovery since, up until that point, astronomers had no idea how far the heliosphere extended. We were aware of a boundary, but we were unsure of its exact location. We were able to unravel that big enigma thanks to the Voyagers. Voyager 2 would follow Voyager in leaving the heliosphere later that day on November 5, 2018, making them the only two human-made objects to do so. Voyager 2 exited the solar system at a distance of 120 astronomical units from the Sun, which was unusual peculiar. Why? Solar activity cycles are regular and predictable, rising and falling every 11 years. According to the scientists' theoretical calculations, the extent of the heliosphere should change on specific dates depending on whether these solar cycles increase or reduce the solar wind. Yet as both Voyagers departed the heliosphere at the same distance and 6 years apart, the heliosphere did not shift during that time, indicating that it is likely far more stable than previously believed and does not fluctuate as much as suggested by theoretical models. Please like the video, subscribe to this channel if you haven't already, and don't forget to ring the notification bell so you don't miss any video. Voyager 1 is beginning to break down. Everything suggests that Voyager 1 is still functional despite its advanced age. The probe's articulation and control system, however, has recently perplexed NASA specialists working on this mission. It is producing data that seems to be generated at random. In particular, researchers found that the spacecraft successfully receives and carries out directions from Earth. The Attitude Control and Articulation System, AACS, of the probe, which maintains the spacecraft and its antenna in the correct position, however, does not accurately reflect what occurs within Voyager 1. The AACS is transmitting useless telemetry data to the spacecraft's manipulators. Engineers are unsure of whether the issue is coming from that system specifically or from another area of the ship. Moreover, according to NASA, the identical probe Voyager 2, which was also launched in 1977, typically behaves. It's possible, according to a number of scientific publications, that NASA won't be able to identify the cause of the issue and will instead need to make software modifications. Instead, as was already done in 2017, use one of the ship's reservation systems. Voyagers are ceasing operations. The crew of the Voyager spacecraft is still reviewing the information that it sends to us from the furthest regions of the solar system. A signal from Earth currently takes 20 hours and 33 minutes to travel to Voyager 1, therefore the procedure is relatively slow. While there is a delay in waiting for the spaceship to respond, a robust radioisotope thermoelectric generator on each probe transforms heat from the decay of the plutonium isotope 238 into electrical energy. This energy is not limitless, though. It will eventually run out, which is why NASA is beginning to turn off some spaceship systems to conserve as much energy as possible. Even engineers have predicted that, in the best-case scenario, the ships will run out of power entirely by 2025 and will then permanently shut down. The Voyagers will be left in total darkness after they shut off, drifting aimlessly over interstellar space. A few thousand years will probably pass close to some stars, and it is predicted that Voyager 1 will exit the solar system and head towards the star AC plus 793888 in the constellation Camelopardalis in 40,000 years. In around 296,000 years, Voyager 2 will get within 4.3 light-years of Sirius. Throughout the history of the cosmos, would any extraterrestrial culture ever come upon these ships? We still don't know the answer to that question, and it's likely that it will never happen, or, if it does, that it won't happen until after mankind has vanished from the face of the planet millions of years from now. It's possible that the Voyager spacecraft survived longer than human civilization, or who knows, maybe someday we'll have such cutting-edge technology that we can cover the same distance in a few days as the Voyager probes did in several decades. How do you feel? What do you suppose will eventually happen to the Voyager rovers? Share your thoughts with us in a thoughtful remarks.